Okay, we'll go ahead and get started. Hello, everyone. My name is Tara Van Cleve. I'm a business development consultant helping Oracle developers, product managers, and developer advocates educate our users about Oracle technology. Thank you for joining us today at Autonomous Database Office Hours, AutoScaling Configuration and Monitoring. We're very excited to be able to share with you how AutoScaling can help you save money running your databases by growing and shrinking the OCPUs based on the incoming workload. If you have any questions during the webcast, please put your questions in the Q&A area. We have a number of solution experts available to answer your questions throughout the session. If time permits, we will also answer questions live after the presentation. This webcast is being recorded and we'll make it available shortly after the webcast concludes. Again, thank you for joining us at Autonomous Database Office Hours, Autoscaling Configuration and Monitoring. This webcast will be presented by Chris Banashali, Senior Principal Product Manager for Autonomous Database Cloud. At this point, I will turn it over to Chris.
Thank you, Tara, and welcome everybody to this webcast. Let me start off by sharing my screen. Okay, hope everyone can see this fine. I'm Chris Banashali, and I'm one of the product managers for the Autonomous Database service on dedicated infrastructure and on Cloud at Customer. So in today's office hours session, we're going to be focusing on autoscaling as the description of the session says. I'm going to start with a short introduction to the Autonomous Database for those who may not be familiar. Very quickly bringing you up to speed on the key aspects of the service. But the crux of the discussion today is going to be about autoscaling. And we will examine autoscaling in detail, look at different monitoring tools which kind of give us insights into how autoscaling is working under the covers. And then we'll end the session with hopefully some feedback from you about future office hours sessions. So I'm hoping most of you who are here today are already familiar with the Autonomous Database and have attended one of the sessions early that talks specifically about what Autonomous offers. But in a nutshell, Autonomous is a service that automates pretty much most aspects most administrative aspects of the database and database management. There is automation built around provisioning so that you can deploy mission-critical application configurations that require Oracle RAC, Oracle Data Guard for replication across regions, etc. So easy provisioning of any type of configuration that would support your application. Automation of security in terms of pre-built encryption for data at rest, data in transit. A lot of other controls over how privileged users can access the database, right? So the data is available on an as-needed basis only. So all of those, features are pre-configured and pre-set up. From a manageability perspective, there is automation around the infrastructure deployment. Patching, for example, is automated. Upgrades are automated. So as an administrative team or as a developer, you are not responsible for patching and those management aspects of the service. Backups are automated, so you're not responsible for backing the database. You do have some controls around when certain events occur, right, based on your applications and your business schedules. But other than that, management is highly automated, which makes it easy for lines of businesses, development teams, DBA teams that handle a large number of databases to easily manage and run this and focus their time on the data architecture and writing the right kind of applications. Today, we're going to focus on one aspect out of these, that is scalability, right? And as we all know, scalability is kind of a promise of the cloud, right? The unlimited scale that the cloud promises. And so we'll take a close look at what Oracle Autonomous Database offers in this space. What are the differentiators in terms of how our scaling works? the online scaling aspect and the auto scaling, and we'll take some look at how a workload responds, right, to scaling operations in real time. Now, you may also know that the autonomous database is available in different deployment choices, right? So it's available on a shared infrastructure where multiple customers may exist on a single Exadata rack. As you know, autonomous database runs on the Exadata platform. So there's the shared infrastructure, and then there's also dedicated infrastructure where each customer or each tenancy can have its own separate slice of Exadata, a shape in the form of a quarter rack, a half rack, a full rack, multiple racks, etc. And so your autonomous database can run in such a dedicated environment in a private network. And the dedicated infrastructure is available in the public cloud regions, one of the Oracle's public cloud regions, or also on Cloud at Customer, right? So if you decide to host the Oracle Cloud environment in your own data centers, you could do that using Cloud at Customer. So let's kind of jump into auto scaling, okay? And each of the bullets on the right, I want to make sure that I get into the weeds of each of them and show you what that actually means in the service. So number one, I think it's important to remember that with Oracle's autonomous database, the database deployment is shapeless, as in you're not limited to 1, 2, 4, 8, 16 shapes, which is typical of a virtual machine-based service, right, which you might know of in other cloud providers. So this is all shapeless. You could start with one OCPU and increase in increments of one and go up to hundreds of OCPUs for that one database without incurring any downtime. So the second aspect is that scaling is completely online. There is no blip. You basically see just the resources becoming available to the database and an uptick in the transactions per second. So we're gonna demonstrate. We'll see all of that. And then that's the manual scaling aspect, right? You could go to the console and scale a database up or down whenever you like. Or using REST calls, you could have it automated and in response to certain business events. So if you have a business event or reporting application, an end of month, end of quarter type of process coming in, you could basically set up a REST call to the autonomous service, which would beforehand scale the CPU up, right, to whatever you need, and after you finish it, you can scale it down. So that's one way of doing it. The service also offers what is known as auto scaling, and when you turn on auto scaling, the service would respond to the workload. And so as your workload increases, if the CPU touches 100%, then more OCPU resources automatically become available for that period of time that you need those resources, and then it goes down once again. So it scales up in response to the workload, scales back down when the workload demand goes away. And that's kind of demonstrated on the left-hand side in this graph, where you see that you set up a baseline number of OCPUs for your service. And then when a business event occurs or the workload goes up and there's more demand for OCPU, the service will provide those OCPUs up to 3x of what you configured the baseline to be. So let's say you set up your workload to run on 2 OCPUs. You can go up to 6, right? So it'll get the additional 4 OCPUs on demand in response to workload, and then relieve them and let go of the OCPUs, turn them back into the pool when that demand goes away. So that's that. So that's great that you don't have to size for peaks, major advantage from a cost perspective, but also the fact that when these peaks occur, your cost is limited to those time periods only, right? So the additional 4 CPUs that you grab, for example, would be billed only for the time period that they're used. So this is truly dynamic pay-per-use, and makes it really easy to size for non-peaks, size for an average usage, but still be assured that when your application requires that surge in CPU demand, it becomes available. Okay, so that is what autoscaling is. And as I said, we're going to examine each of the bullets on the right-hand side, the shapeless nature of it, how you scale up and down, the scalability, how do you scale on demand. We'll try and demonstrate really how, pay-per-use means, right? Pay-per-use has to be real, has to be usable. If you have to turn your database off or shut down a machine, then scalability basically has no meaning, right? So we'll see how that works in the autonomous database. Also, we'll look at some of the billing aspects later on and see how you compute the usage and take a closer look at what exactly you are paying for on a per database basis, right? So with that, we're going to jump into the test environment. And a quick introduction to what the autoscaling test environment setup looks like. So what I've done is in the Oracle Cloud Infrastructure region, in a virtual cloud network, I've set up two subnets, right? One is a private subnet in which my Exadata infrastructure, my dedicated autonomous database environment is deployed. And to access it, I've set up another subnetwork. It's a public subnetwork which has a developer client machine, right? So we're going to use that machine to drive the workload, and we'll connect to that particular virtual machine over the public internet. So I'm going to SSH. I'm going to SSH create an SSH tunnel, and connect to this virtual machine 5136.89.112. Okay, and then I have a few tools that are set up, pre-configured and already running. One of them is a workload generator that we're going to use to drive our workload. And then there's SQL Developer and some other monitoring tools with which we can keep an eye on how things are doing. Okay, so that's my basic setup. And in terms of testing of autoscaling, there are two tests we're going to run, right? We're going to first baseline it with, in the workload generator, we'll start with 4 users, okay? And we would have a 2 OCPU database deployed. So 2 OCPUs is equal to 4 threads. And so 4 concurrent active sessions can run in the database, right? So your 4 users who would be constantly active running transactions would be serviced by this 2 OCPUs fine. That is what the expectation is, and we should not see any wait time. So we're going to monitor wait times and transaction throughputs. Then we'll increase that to 6 users, right? So we'll increase the number of users to 6. So the expectation is, yes, there'll be some session that might be waiting for CPUs. So we'll take a look at that. And then we will manually scale the CPU to 3, which gives us 6 concurrent active sessions, right? So the expectation is, again, the waits should then go away. Okay, so that's test case 1, manual scaling. We'll see how it is done online. We'll see what transaction throughputs we get. We'll take a look at, is there any blip from an application perspective? How does it run, etc. Okay, so that's test case 1. We continue that in test case B by basically, now that we are on, with 6 users and 3 OCPUs, right? So we're going to bump up the users to 8. And so when we bump the users up to 8, we'll see the weights reappear, right? The CPU quantum weights will reappear. And so this time we'll solve the problem in a different way, right? So instead of manually scaling the baseline up to 4 so that we can now support 8 users, we are going to turn on autoscaling. So our baseline stays at 3, we turn on autoscaling, and then we monitor the CPU wait events, and we'll look at how much capacity then becomes available, right, to the database. How far can I go and take my workload to? And then what happens when I scale down, right? And so that will give us some clear ideas about what happens under the covers, how Resource Manager allocates CPU resources to active sessions, and then we'll end with looking at what advantages does this method offer, right, over manual scaling. And perhaps also look at the billing side of it, how billing is computed, and I'll show you where to look for billing information in the service as well. So I'm going to stop my video here so we can get more bandwidth. Okay, so let me start by first creating that SSH tunnel to my developer client machine. So on my terminal, I'm going to run this SSH command that connects me to 51.36.89.112 as we discussed. And then I'm going to start a VNC session. So this VNC session is pre-configured. All right, so I'm connected, and here's the workload generator. Here's Swing Bench. And to connect to it, I basically need to provide it the connect string, which I get from my database console. And then everything is basically encrypted. So my encryption wallet is something that I downloaded from my cloud console, and I provide it here. So my connection from my laptop here over the SSH tunnel, even though it is an SSH tunnel, it's still encrypted, and so I'm secure. Okay. The workload itself, this will give you an idea about what the workload is. It's a mixed workload pretty much, with a high level of reads through product browsing. It's an order entry application basically, and there are queries that browse orders, process orders, update them, register new customers. An occasional sales rep query, which is more of a reporting type of a query, and then a data warehouse extract. So some of those ad hoc extract requests that come in once in a while. So try to make it a mix of a very typical OLTP mixed workload that you would see. Okay. And then we're going to monitor the transactions per second. So this is what we're going to keep an eye on, the TPS, once we fire it off. We said we're going to start it off with 4 users. So you can see I have configured 4 users. And I'm not going to use any sort of connection pooling here, right? Although practically you would, but this is just for simplicity and to demonstrate the number of sessions being proportional to the number of users. Okay. So let me fire this off first. So I fire this off, and you can see the sessions are logging on. I'm up to 4 sessions here, and slowly the transactions would build up. I expect around 1,000 transactions per minute. So let's take a look at the database in the meantime while this builds up. I go to my cloud console. I'm already logged in, and I go to the transaction processing or autonomous data warehouse. Both will take you to the autonomous service. And I'm logged out, so I got to log back in. Okay, so I'm in my autonomous database environment. Everything is by compartment, so there are hundreds of databases running here. But as a compartment owner, I can only see the 2 databases that I have created here. So it provides a nice separation within the tenancy. We are using this database here, basically, the AutoScale test database, which is deployed on dedicated infrastructure. And you can see that currently there are 2 OCPUs assigned to it, right? And all scale up, scale down, auto scaling operations from the console are done via this scale up, scale down UI, right? So you basically can bump this up in increments of 1, and then you check this box off, and this turns on auto scaling. So it's as simple as that. Okay, so we're going to start off with 2 OCPUs, no auto scaling. Okay, and what do we expect when that happens? That everything should be fine and dandy, because I have all the horsepower I need to run that workload. So I'm close to about 800 to 1,000 transactions per second. And we'll monitor the weights using a monitor tool called DB Monitor. This is already set up as well. So yeah, so this is the kind of a visual tool we're going to use to monitor CPU quantum weights. And right now you can see that I am getting all the CPU time for my database queries, roughly about 85%. And then the other is being used for other events as well. So that's that. Let me also show you some screenshots that give you a better idea, because this might not be big enough to visualize and see. So yeah, this is a DB Monitor tool. I took these screenshots earlier and enlarged them. But when we see session weights, you'll see that the sessions that actually grab CPU time or are using CPU time are in this dark green color. And those that are awaiting, basically, for CPU, known as, they're shown by this CPU quantum weight here. And they appear in light green in this graph. So you can see these are all sessions. So you can see the breakup of the total number of sessions, and then how many of them are actually active and working, right, with CPU available, and how many of them are actually in a wait state. Okay. We're also going to look at a $V view. So this is basically a PDB metric dynamic view, RSRC PDB metric. There is two of these. There's RSRC PDB metric that gives you, the last minute data. And then there is RSRC PDB metric _ history that, gives you a minute by minute history. So if you want to look back for an entire hour, then you would use the history table. In this case, we just want to see what happened as we dynamically do stuff. And so here I'm pulling these tables that have that show me the CPU wait time. They show me the num CPUs, and they show me the running sessions limit and the actual average running sessions. Okay, and what do these mean? So num CPUs is actually the number of threads available. And so once again, now this is a differentiator compared to, say, at AWS, where one vCPU is equal to one thread. In the Oracle Cloud and Oracle Autonomous Database Service, one OCPU is equal to 2 threads. So it's actually twice the horsepower, even if you just compare apples to apples to an AWS vCPU. Okay. Okay. So here now with 2 OCPUs and 4 num CPUs, right? We are able to run a maximum number of 4 sessions, 4 active sessions. And so we're going to keep an eye on that. And then the average sessions is what is really running, the average over the last 1 minute. So when I see this to be a 4, then I know that I'm basically using up all the CPU that I have available, correct? And so we're going to use this SQL to monitor how AutoScaling is impacting the running sessions and the number of CPUs that become available to my database. Okay, so let's go back to our workload generator. And so we said that we're going to start with 4 CPUs. So we did that. There should be no weights, and I think we see that there are no weights. Let's go back and reconfirm that. There are no CPU quantum weights, right? So all of the 4 sessions are busy servicing customers, and my database is chugging along just fine, although pretty much close to full capacity, but there's still some CPU cycles available. Now let's see what happens when I bump this up to 6 users, right? So we're going to stop this. Unfortunately, I cannot do it in real time. The app only allows to start from a stopped state if you want to change the number of users. So I'm going to bump this up to 6, and we're going to restart the workload. And you can see now I'm logging up to 6 users. Okay, so we have 6 users. Let's take a look at what DB Monitor shows us here. Okay, so I can see that the CPU quantum weights are coming in, right? You can see about 22% of the sessions are waiting on CPU. For some reason, this graph is not updating. I probably will have to shut this down and restart it. And I have taken screenshots ahead of time so you can see what that looks like. Let's go back to the PowerPoint. So we've seen this. These are okay. So there you go. So we have bumped up the users to 6, right? Num CPUs is still 4, and we see this CPU quantum weight. So the graph should actually look like this if it appears. But even this, the table on the right-hand side kind of gives you an idea that you see the CPU quantum. 73% of the sessions are active with CPU time, and about 18% here are waiting on CPU. So you can see that here. Okay, yeah, this is updated now, so perfect. So you can see the CPU quantum weights here. Okay, now what we do is, while this is running, we will go back to the service and we will scale up the number of CPUs to 3 from 2. Right, so the OCPU goes up to 3. That means num CPUs goes up to 6, and I should be able to support 6 users. So I go back to my database console, and this time I actually say scale this up to 3. I issue the update. And the other thing to notice is this takes about a minute or 2 to take effect, although on the console it might take a little bit longer, but in the backend it's actually faster. So if you keep an eye on this, then within a minute or so, we should see the quantum weights go away. Now, there's a few other ways to monitor this, even within the service. But given that this, we are doing this pretty much real time, I'm using this method as a better way. But there is a monitoring capability within the service itself, right? So if you go to more actions, if you go to tools, then you see this database actions tile, right? And if you open that, it gives you an access URL. You just copy this access URL, and if you drop it in a browser that has access to your database, so in my case, I will need to go back to my VNC and open up a browser. And drop this in here. Okay, for some reason. There you go. What this does is it gives you a complete SQL management tool. So this is, think of it as an IDE. I wouldn't call it a complete IDE, but it's a pretty decent version of SQL Developer that you get in the browser with capabilities to, of course, code in SQL, PL SQL, run traces, for example, run explain plans on your SQL. And also, if you need to load test data, then all you have to do is basically drop your CSV or Excel file right here, and then bang, it is in your autonomous database. So it really makes it easy, and you don't have to go anywhere else. So this is another way, and then you can also monitor stuff here, right? There's you get Performance Hub that allows you to look at performance. For example, just like I was looking at the active sessions, I could look at that right here, right? So you can see that my CPU weights which just started as I bumped up the number of users, and before that they were quite low. So you can see that this is quite real time, but maybe not as real time as that Java app that I that I had pulled up, and that's the reason why I'm using that. But I think in practical applications, when you have a workload running for a while, this could be a pretty decent go-to place for you to keep an eye on your database and what's happening in there without the need for additional tools. Okay, so let's go back and take a look at what happens to my quantum weights. So they have gone away. And of course, this graph is once again not updating as expected. But you can see that, once again, I'm back to CPU time. And if I run the SQL query, let's try and run that in SQL Developer. The query against the RSRC PDB metric table and see what comes up. Okay, so as you can see, of course, because I scaled up to 3 OCPUs, I now have 6 num CPUs, right? That's that. The running sessions limit is 6. Of course, I can have 6 active concurrent sessions that are using CPUs. And then you can see that I'm almost up to 6. I'm up to 5.9. So this gives me a sense of what my usage is right now, okay? There's also a column that I've not included in the screenshot, the average waiting session. So you can even look at this and tells you how many sessions are actually waiting for CPU, right? So very little, which tells me that I'm doing okay. I'm throttling my CPU pretty much to the max, but nothing is basically getting blocked on CPU. Okay, so that's my manual scale. Now, when I do that, when I scale manually, I am now locked on 3 CPUs, right? So even if this workload goes down, my baseline has changed to 3 OCPUs, and I would continue to get billed on these 3 OCPUs unless I go and manually scale them down, right? So not a bad way of doing things. You could do that too. Again, as I said, you would automate it using REST scripts, which can bump this up and down. And as you saw that in terms of the workload, it doesn't, you don't have to bring anything down. The application continues to run. And so you can do this in real time as often, as frequently as needed, 10 times a day, as many times as you need. But let's look at a different way of doing this. So we'll now jump on to test case 2. So we saw we saw the test case 1 where we bumped the number of users up, then bumped the number of OCPUs to 3, and the problem went away. In test case B, we now increase the user to 8. So with that, we should see the weights reappear, right? And then we're going to turn on auto-scaling while keeping my baseline OCPUs to 3. So let's go ahead and do that. So first I go to VNC, go to my workload generator, and stop this so I can bump up the number of users to 8. Okay, rerun the workload. And you can see 8 users are logging on. Okay, and now instantly I should see my DB monitor show these quantum weights reappear, which you can see in the table better than in the graph. Yeah, so the quantum weights have jumped. About 20% of the sessions are waiting, 25% on CPU. Let's go back and reconfirm that in using SQL. So if I run a query against my PDB metric table, once again, this updates every minute. And so this might take another few seconds before it shows me the real-time status. Yeah, this is because I stopped. So you can see that it's actually showing lower average running session because for a few seconds I had stopped the workload generator there. But we'll come back to this. We'll come back to this. Let's give this 30 seconds. And in the meantime, I'll show you that if I want to scale up or down, I'll now just turn on auto scaling here. Okay. Let's go back to the service. check one more time. Okay, so now we see here that, well, I'm still limited to 6 CPUs and 6 sessions, right? Because I'm still at 3 OCPUs. And I'm pretty much maxing out those 6 because my average running sessions are about 6. But you can also see that there are 2 sessions approximately that are waiting, right? So that confirms what I also see in the DB monitor here. About 20%, 20-25% of the sessions are waiting on CPU, okay? So this is where we stand. Let's go back to the service and turn on AutoScaling now. So I go back and leave the baseline at 3. So I just issue this. Now we'll have to give it another minute or so for the AutoScaling to take effect. And let's see what we expect. I'm going to show you what the expectation is here, is that number one, we of course bumped the users up to 8, and there were wait events, which were not clear on the graph right now, but just about 20% of the sessions were waiting. By the way, this session is going to be recorded, so you can even go back and take a look at the recordings. I've not talked about this extensively right now, but we've also been watching the transactions per second, so you can even see that how the transactions per second go up and down as you scale up and scale down. So as I went from 3 to 6, there were some cycles available, and so my TPS went up to 2200. In the previous test, I was on 3 OCPUs and 6. I got about 1800. So there, whatever little headroom was there, I did get that throughput increase in TPS, although I'm now basically totally maxed out, right? And you can see that there are CPU waits. And now, when I turn AutoScaling on, here's what happens, right? First of all, AutoScaling allows you to go up to 3x the number of OCPUs assigned, right? So I can go from, I can get up to 9 OCPUs. And since each OCPU is equal to 2 threads or 2 num CPUs, 9 OCPUs would now be 18 num CPUs. So I can actually have 18 num CPUs. That's what's going to show up once this takes effect. And then, of course, my running sessions limit now can go up to 18. And then the average running sessions will actually show you the actual running sessions, right? So we will take a look at that. So let's go back and see. I'm hoping that definitely this should be done by now. So there you go. At this point, you see that the quantum weights have gone away, right? So once again, no weights, and all of my sessions are pretty much getting the CPU they need. Let's take a look at the RC PDB metric table. And so here, once again, you can see the CPU weights are gone. My num CPUs are 18. 18 is my limit. That's the max number of running sessions I can have. And then the average sessions right now with 8 users, about 7 something, right? So I have enough headroom now. If my users go up to 10, 12, I know that I'm fine because I have enough OCPUs available. But at the same time, the important thing is that I've done it by keeping my baseline OCPUs to 3, right? So that's the important thing. And the fact that I'm going to get billed for my average running sessions, right? So I'm not getting billed for 18 num CPUs or 9 OCPUs. I'm still getting billed for what my actual usage is. So huge difference. And now next, we can go back and scale this down, and we'll see that my average running sessions come down, even though my num CPUs remain the same, right? So let's go ahead and finish that as well, and we can come back and talk in detail about what this actually means and what the impact on your billing is as a result of this. So I am going to go back to the service, to the workload generator, and scale my users back down to, so by the way, you can see the transactions per second is about 2,400 now, which is in line with expectations. So I'm going to stop this, turn this down to say, I'm back down to say 6 users, right? So I'm back to 6, fire it up. And let's see what the DB monitor shows. Yeah, the DB monitor should not show, I mean, it should, as you can see, the throughput has gone down, right? So you just, of course, there's less CPU needed. And so there are fewer sessions, of course, but no waits in the previous case or now. What the impact really is the ability to get CPU as you need it and, basically just paying for what is being used. So that's the major advantage of using AutoScaling over manual scaling. Okay, so once your CPU goes down to 6, this is the expectation. The average running sessions you will see will drop down to around 6 if you're maxing out on the 6, and then that's basically, then you continue to get billed for 3 OCPUs, which is your actual usage. Okay, so I hope this explains, everything, pretty much everything that we discussed. We talked about how you can increment in, 1 CPU increments, so you're not tied to any specific shapes. Also, you're scaling on demand, either manually or using auto-scaling. And when you do that, your billing is limited to the actual usage. So this really is true pay-per-use. Let's now finally have a look at the billing information, right? So we'll go back to the service now and look at where I can see my usage and billing, and how I can break it down by the hour. So go back. So in my service here, in the account management section, you have something known as cost analysis, right? So if you go to cost analysis, and right around here, you can specify a time period. You can specify how granular you want this report to be, daily or monthly, and either go by cost or by usage. Okay, so if I go by usage here, I can even filter down to a specific resource. So if I say my resource OCID here, let's say I drop my autonomous database OCID and then run the report, I can get a report for that specific database only. So it's very granular. You can keep an eye on a specific resource on Exadata infrastructure, or if you simply want it for your entire service, you could just say apply, and it'll generate a report. Now, unfortunately, since my tenancy here is actually a test tenancy, I do not get this, but I was able to generate some reports from another tenancy that had the capability and have some screenshots to show you what that looks like. Here I'm running by service. I'm running a report for about a day, and I wanted to show me the cost, so you can see the cost here on a daily basis. Then I go to again, I'm trying to set up a filter. I drop in my autonomous database OCID, right? You can grab that from the Cloud Console. And when you do that for that specific autonomous database, you get a breakdown. You can see what your costs are. And you can see that for that particular day, my cost was some $41 US. Also, you can download a CSV that gives you an hourly breakup of all your costs across all the resources, and then you can filter that down. So I actually have that CSV, which I can show you. Okay, so you get to see the start time and end time, the resource IDs. This is basically the OSID of the resource. And you can see the product description. I filtered it down. So, there's definitely all the products that are there in the OCI ecosystem are here, but I have filtered it down to the autonomous, because that's what we're talking about here. Autonomous database dedicated. You can see the cost, the unit price, about 89 cents. And then if you look at the quantity billed by hour, for each hour, you can see that you used up, 28, 73, etc. And so if you multiply this number by this number, you get your actual cost, right? Also, you can see that auto-scaling has been used here because there's fractional OCPU cost here, which is amazing because, as I said, you get billed for what you use. So I've used 73.86 OCPUs here times 0.8984 gives you 66.36, etc., etc. Okay, so you can on an hourly basis break it down, filter it down, and as I said, it's you can specify a specific resource and get it down to that one database that you might be watching out for. Okay, so very granular billing. This report gets generated for the past 24 hours. And so you can look back on, say, yesterday and break it down by an hour. Okay, so that's on the billing side of things. All right, so we discussed scalability in great detail today out of the many different aspects of the autonomous database and the automation that has been built. And if there are other areas that you were interested in, to drop your thoughts in the chat or let us know, and we'll set up sessions accordingly. The other thing to keep in mind is, and as we have seen today, is that the autonomous database is built for rapid application development, right? Rapid development, but along with all the other important aspects of availability, security, and cost. We looked at database actions and the capability for developers to have a single integrated environment to manage and monitor their autonomous databases. There's also Apex that comes built in. Apex allows you to build applications on the database without the need for any middle tier. And it is also a low code environment. So people with very limited development or coding skills can build production grade and rich applications. And then also, if you're building, JSON apps, right? If you're not a SQL person and you're writing code in building JSON, that the autonomous database takes and interacts directly with JSONs. It'll ingest your JSON data coming from your applications over REST. And so even in the absence of any SQL development skills, you can use the autonomous database just like a NoSQL database. So with that, I end my session today, and I'm going to turn it back over to Tara.
Thank you, Chris. So here we have some additional resources and also some ways to keep in touch with Chris as well. We hope that everyone enjoyed spending your time here with us today and that you found it very valuable, and hopefully you'll join us again next month for a REST API deep dive on May 4th. So thank you everyone so much. And again, thank you for spending your time here with us today. Thank you again and have a great rest of your day.